Hi class, this is Miss Best. This video is about solving quadratics by square roots. Now solving quadratics by square roots is pretty simple. There are three main steps. The first step is isolate the variable. The second step would be to take the square root. Okay, and the third step would be to put your plus or minus in front of your answer. Alright, and the reason why we put plus or minus in front of our answer is because when you take the square root of something, the root could be a positive or negative number. Because we know that let's say for instance, if you have 16, you take the square root of 16, you automatically think 4. But in reality, it's a plus or minus 4. Because the definition of a square root is a number times itself. It multiplies to be another number. Okay, so 4 times 4 is 16, okay, and negative 4 times negative 4 is also 16. So we have to account for these two different scenarios by putting the plus or minus in front of our answer. Okay, so let's get into the first example. The first example is p squared equals 9. Now the first step is to isolate the variable. Okay, our variable is already isolated. There's nothing over here by p. So I can move on to the next step, which is square rooted. Okay, so I'm going to square root both sides. Okay, the square root of p squared is p, because p times p equals p squared. And then the square root of 9 is going to be a plus or minus 3, because it could be positive or negative. And for this question, you are done. Okay, pretty simple. Alright, let's go on to the next example. And if you need to copy this down and I'm going too fast, just pause the video. Alright, the next example, 75q squared minus 3 equals 0. Alright, our first step is to isolate the variable. So we're going to use inverse operations to isolate the variable. Okay, so the first thing I'm going to do is add 3 to both sides. Okay, these 3's will cancel out. 0 plus 3 is 3. And then I still have 75q squared over here. Alright, next I need to divide both sides by 75. Okay, these 75's will cancel out. And then I have q squared equals 3 over 75. Alright, so I know that 3 over 75 can be reduced. So I'm going to go ahead and reduce that to 1 over 25. Okay, now I'm going to take the square root of both sides because my variable has now been isolated. There's nothing else over here, so now I can take the square root. Okay, remember to take the square root of the numerator and the denominator. Okay, so now the square root of q squared is q, and then the square root of 1 over 25, we'll do it the numerator first. The square root of 1 is 1, and the square root of 25 is 5, and don't forget your plus or minus. Okay, if you need to watch that again, please rewind the video and watch it again. Alright, so I'm going to go on to the next example. The next example is 2s squared equals 96. Alright, so I'm going to divide both sides by 2 because I need to isolate the variable. So I have s squared equals 96 divided by 2 is 48. Alright, so my variable is now isolated. Now I need to take the square root. So I'm going to take the square root of both sides. The square root of s squared is just s. and then I have the square root of 48. Now 48 is not a perfect square, okay, but you can simplify it, all right, and in IXL they're going to want you to simplify it as much as possible, simplify it all the way down, all right. Now 48, the square root of 48 can be simplified because there's a perfect square that is a factor of 48. And when you do your IXL, you're going to need to use your perfect square chart so that you can find the largest perfect square that is a factor of this number. Okay, so let's add a step. If we need to simplify, find the largest perfect square that is a factor of, and that number underneath is called the radicand. So I'm going to write that, radicand. Okay, in our case for this example it's 48. Alright, so I know the largest perfect square that can go into 48 is 16. So that's going to turn my the square root of 48 into the square root of 16 times 3. Now I can take the square root of these numbers individually, okay, because they're multiplying. Now the square root of 16 is 4, and 3 is not a perfect square, and the only perfect square that will go into 3 is 1. So we're just going to keep that the square root of 3, okay, and don't forget your plus or minus. Alright, so the next part of this video is talking about the different types of solutions you can have with radical equations. Now, you can have 3 types of solutions. You can have 2 real solutions, you can have 2 imaginary solutions, and you can have 1 solution. Okay, so if you are solving a problem, and if you're solving a quadratic by square root, and after you isolate the variable, the right side of the equation is positive, then you will have 2 real solutions. So I'm going to do that example first. So here's my example. I have y squared plus 15 equals 87. Okay, I'm going to isolate my variable, subtract 15 from both sides. These 15s will cancel out. And now I have y squared equals 72. Alright, so 72 is a positive number, so that means I'm going to have 2 real solutions. Okay, now if I do, if I solve my, isolate my variable and the right side is negative, that means I'm going to have 2 imaginary solutions. So I'm going to show you that. So I have z squared, negative z squared, I'm sorry, equals 7. So I need to isolate the variable first. And since this negative is here, I have to get rid of it. So I'm going to divide both sides by -1. And now I have z squared equals -7. Okay, -7, that's a negative number. So that means I'm going to have an imaginary solution. Okay, and then next is going to be the real solutions, and you have one real solution, and you have 1 real solution when your right side is equal to 0. Okay, so here's my example, b squared equals 0. Okay, so if the right side equals 0, then you're only going to have 1 real solution. Okay, all right, let me go over that again. So if the right side is positive, you have 2 real. Okay. If the right side is negative, you have 2 imaginary. And if the right side is 0, you have 1 real solution. Alright, so make sure that you get these notes in your notebook, and then come with any questions that you have tomorrow. And I'll see you tomorrow. Bye.